Welcome back to the last section of Chapter 8, Trigonometry. So again, in all of Chapter 8, 8.1 to 8.5, we've been using right triangles. Section 8.6 is our fallback if we don't have a right triangle. So in Section 8.6a, we talked about law of sines. Section 8.6b, law of cosines. And we're going to solve triangles in this section. I don't know if you remember, but solving triangles means to give all the information that you don't have. So law of cosines is a little bit messier. Let's look at the pattern. It sort of has a little reminiscent of Pythag. So a squared, side a squared is equal to side b squared plus c squared minus 2 times b times c times the cosine of angle A. So I want you to notice a couple things here. First of all, our beginning and our end, side A and angle A. Those two things are always going to start. So your angle and the opposite side are the start and the beginning. So always watch for that. So then we take these other two sides, b squared plus c squared, so that's our other two sides, minus 2, repeat the b and c. And because it's law of cosines, we use cosine in the formula. Not sure if you noticed, but in section 8.6a, the law of sines, we only use sines in the formula. So let's talk about a couple things here. Then we'll do some practice. Non-right triangles. Again, why would we do this if we had a right triangle, right? We could do trig or SOHCAHTOA, Pythag, something like that. Our given information, we're always going to have 3 pieces of information. It's either going to be 2 sides and the included angle. I don't know if you remember back, but it looks like side angle side. Or you'll be given 3 sides of the triangle. So still 3 pieces of information, just like in law of sines. To me, this one's harder, more confusing, more room for error with all the numbers adding, subtracting, multiplying, dividing, everything. So I use law of sines when I can. This is what happens when I can't. Remember, we always have in law of sines an angle with its opposite side. Well, this one, we don't have that. We have one angle with its opposite side, but we don't have any other angles. And last but not least, I'm sure you know that I was going to tell you I need to see all your paper and pencil work first. Crucial. So let's do an example or two. I think we'll start off with, let's just do example 1. That seems like a good place to start. It says to find side A if C is 8, B is 10, and angle A is 60. Round to the nearest 10th because we're finding a side, right? So notice, again, it's important. We've got to have a pair. So an angle with its opposite side, even though we don't know side A, that's going to be the beginning and the end of our law of sines. And then we've got our other 2 pieces of information. So you've got yours written right there. Let me write mine down really quickly so we can see the pattern. So a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Now, if you didn't like how these things were, I set this up nice and neat. You could always change letters on your triangle, but sometimes once you see the pattern, it really helps. So a squared, that's what we're looking for, right? Notice it's squared. Probably our last step will be square rooting. Equals, does it matter which one's B and C? It really doesn't, but we know that B is opposite side B, C is opposite side C. So we'll do 10 squared plus 8 squared minus 2 times, repeat the side B, which is 10, repeat the side C, which is 8, and then the cosine of our angle, which is 60. Remember, it's a matching pair, the side and its opposite angle for the beginning and the end. So at this point, paper and pencil math first. Some of you need to go way back because some people are going to try to subtract before you multiply. So let's do a couple of things. Some of you are just going to type this straight into your calculator. It's going to drive me mad, but you're going to get the right answer. So there's that. So when I do this, 10 squared plus 8 squared, that's like 100 plus 64, right? Your calculator can double check, verify that that's 164. When I do all of this, before I can subtract, order of operations, PEMDAS says I have to do any multiplying before I do any subtracting. Subtracting and adding are our last things. So I can't subtract, I can't do 164 minus 2 equals, and then multiply 10 times 8 times cosine of 60. I have to do all this multiplying first. So I'm just going to do the 2 times 10 times 8. I believe that's 160 times the cosine of 60 degrees, a minus sign in the middle. Feel free to go ahead then and type that into your calculator. I'm pretty sure when I did that, it ended up being a nice, neat number, which is unusual. You're welcome. I think when I did that math, I ended up with a squared is equal to 84. So then if a squared equals 84, everybody knows how to do that. Square root both sides. So a is equal to, if it does say to round to the nearest tenth, so I can round that. That's going to come out to approximately 9.2. If we were being exact, we could say that a was equal to, I think that would be 2 times the square root of 21. But I am perfectly okay, since it tells me to round my answer, I'm perfectly okay with a 9.2. Once you get the hang of plugging these in, they're not quite so bad. Let's skip all the way down to solving a triangle. So I think it's example 4. We could talk about these ones where we're looking for an angle. Look at example number 3. It says to find the measure of angle R. Let's worry about those when we're in class. We'll work through those ourselves. Let's talk about solving a triangle. I'm pretty sure at this point we have mentioned that when you solve a triangle, you find all the angles and sides. Here's my philosophy. Use some old stuff here, people. Use the law of cosines once if you have to. Then switch to law of sines if you can. Don't forget about the triangle sum theorem. Don't forget about Pythag. It's all there. If you know to use it, you can use it. So sometimes you can't get away without doing at least one law of sines or one law of cosines. So in example 4, it says to solve triangle KLM. So in other words, I need to know angle K, angle L, angle M. I probably know a couple of those. I need to know side K. I need to know side M, which is 14, and side L, which is 18. And I could write in, right, angle K is 51. That's all I know at this point. So what do we want to do first? We cannot do law of sines because angle sine of K over K is really great, but remember I have to have another angle, so sine of L over 18 or sine of M over 14, I don't have another angle. So I have to do one law of sines. So I start and end with my matching pair, so I know I'm going to have K squared is equal to my other two sides, a squared plus b squared. It doesn't matter. If you want to rewrite these as a and then make it b and c, feel free to do that. That's perfectly okay if that helps you to figure out where everything goes in the formula. I like to use the pattern. So k squared, side k squared is equal to my other two sides, 14 squared plus 18 squared minus 2 times, repeat those angles, or sorry, repeat those sides, 2 times 14 times 18 times the cosine of 51, because I start and end with side K and its opposite angle. So then I can go ahead and I can do some math. 14 squared plus 18 squared. I did this math earlier and I got 520 minus, I'm going to do this math and get a 504 times the cosine of 51. Notice I'm not just multiplying 2 times 4 times 18 times cosine of 51 because I'm going to get an irrational number there. That's why I'm holding off. So now I'm going to go to my calculator and I'm just going to type in 520 minus 504 times cosine of 51. Do not do an equal sign after the 504. It's not 16 times the cosine of 51 because we all know order of operations. So when I did that, I'm not clearing out my calculator. I'm just going to jot this down so we have something to refer to. I got 202.8 something something something. So don't clear out your calculator. I'm going to square root both sides because that's what we know we do. So I'm going to end up doing the square root of the answer. I don't want to take a rounded number and then have to round that again. If this is a side, I'm going to round to the nearest tenth, but only at the very end of the problem. So it looks to me like side k is approximately, what, 14.2, I believe? So side k is about 14.2. So now I've got two things left to find, angle L and angle M. You can pick which one you want to do. Let's find angle L. I'm going to make this an X. So let's see, maybe I should make myself a little room over here, huh? Kind of crowded. Don't you wish you could small up your work like that? Okay, so we had said this was A if you were trying to keep track of things. So if I know that, now I can set myself up an equation. I'm going to use law of sines. I cannot use any SOHCAHTOA here because it's not a right triangle. So I'm going to do law of sines, and I said I was going to find angle L next. So I can use my number. I'm always a little nervous when I use my own answer because what if I screwed up on when I found 14.2, but it's all I've got. So I'm going to do sine of 51 over that 14.2 equals the sine of angle B, or angle L, X, whatever you want, over its opposite side, 18. So I chose to ignore angle M. You could have done angle M first if you wanted to. So when I cross multiply, I'm going to have 14.2 times the sine of X equals 18 times the sine of 51. Old-fashioned equation, right? First thing, if I'm trying to get this X by itself, I can't get rid of the sine until I get rid of the 14.2. So I'm going to divide both sides by 14.2. And then what is our big red flag going off in your mind? How do you separate a sine from your X? We don't care what the sine of X is, we care what X is. So in order to get rid of a sine, its inverse operation is inverse sine. That leaves us with just an X. So I'm going to inverse sine. So when I go to my calculator, I do the 18 times the sine of 51. I hit an equals, divide by 14.2, and then I'm going to inverse sine that answer. So I got that X was approximately 80. Double check and make sure I'm right. Again, remember, angles I'm rounding to the nearest whole angle, whole degree. Sides I go to a nearest tenth. So I feel pretty good about an 80 there. That was X, or angle B. Nope, or angle L. So that we said was about 80. So now you want to do this the easy way or the difficult way? By the way, we probably can't do Pythag up here, can we? Because we don't have right triangles. No right triangles. So probably solving with that wouldn't help, but we can use the triangle sum theorem. We just found out that this angle was about 80. We know that angle K is 51. Do you want to do another law of sines, or would you prefer to just use our triangle sum theorem? 80 plus 51 is 131. Subtract that from 180, and I believe that would be a 49-degree angle. And we have solved our triangle. Every time you solve, you'll be given 3 pieces of information, and you'll find 3 pieces of information. So our new things that we just found that we had to work for were angle L, angle M, and side K. So we'll do some practice with those. That is it for Law of Cosines. Thanks for hanging in there for this section and the whole chapter, and I will see you next time around.